Hi, I'm an old guy and I do maths. Today we're going to find the equation connecting the points shown. Now, the points that were shown are shown in the header to this video, and the two equations are y equals x squared plus 5x plus 6 and y equals x cubed plus 5x squared plus 3x minus 4. Now, this is typical of an exam question because there's a hook in it. So I've just drawn a very rough diagram of what it is we're looking for. Now you'll note that the question mentioned these 2 points. Well, they were the 2 points of intersection shown. There's a third one that will occur up here. And so when you get to working this out, you're going to wind up with 3 solutions. And if you're not careful, you're going to be scratching your head. How can you get a line from here to here to here, a straight one anyway? No, in fact, what you have to do is you have to discriminate and you have to find the points shown in the original diagram. Okay, so let's get to that. So this is not as difficult as it seems. What it involves, first of all, is finding the point at which these two equations are equal, which means that we make this equal this. And when we do that, we are able to put them together and find out where they equal 0. Now, in this line here, what I've done is I've grouped everything together in order of magnitude. So x cubed plus 5x squared minus x squared plus 3x minus 5x minus 4 minus 6. So essentially what I've done is I've moved everything from this side of the equation over to here, made it all equal 0. When you tidy this up, you get a cubic. And the cubic is x cubed plus 4x squared minus 2x minus 10 equals 0. Now, where that cubic equals 0 is the point, or the set of points, at which these two functions will intersect when graphed. Now, this problem is about explaining the method of doing this. So everything's been worked out. And you'll notice that if you try this, that I've done quite a bit of rounding. The idea is not to make this video too long, but to make it an explanatory video. So when I solve this, just using a calculator, that's probably the only way you'll do this, unless you fancy using the cubic formula, which is a really nasty piece of work. When you solve this, you get 3 solutions for x. This one, and this one. Now note, these 2 are negative, and this one is positive. If we go back to our drawing, on my rough sketch, what we're looking for is we're looking for these 2 negative ones. The positive one, which is approximately here, where these things will intersect, is not what we're looking for. That's not what the question asks. So, if we take these two values and put them into either of these equations, what we get is we get a set of ordered pairs. Negative 3.843, 1.555, negative 1.693, positive 0.401. Now, these are our 2 points of intersection. They are these 2 points. We were asked to find the equation connecting those points. It's a linear equation. And so the first thing we do is we work out the gradient of that equation. And it's simply y2 minus y1 over x2 minus x1. It is rise over run, however you want to do this. The answer that you get is negative 0.537. which again, in terms of our rough drawing, and again if you want to look back at the header, is not unreasonable. We're looking for a negative gradient. Where do we go from there? Well, what we've got is we've got a gradient and we've got some sets of points. So there's not much to do except get out the calculator, because we've got a few awkward numbers. What we know is that y is equal to negative 0.537x plus c. Sub in some values, which I have done here. 1.555 is equal to negative 0.537 times negative 3.843 plus c. We can work out c from this, as is fairly obvious here. And by the time we've worked out what c is, we've got our gradient, we have our equation. That is the equation connecting these 2 points. And that kind of makes sense. It's always a good idea to draw these things so that if you come up with a negative value here, or a positive value here and a positive value here, then you know that something is amiss. Please note that this is very much an approximation. You'll see that connecting my 2 dots roughly, I got a positive answer here. In fact, the real answer, this point is probably higher, this point is probably lower. The real answer looks something like that, but it's good enough. It gives us an indication. Anyway, thank you very much for watching. I hope you found that useful. If you did, please like and subscribe. Tell a friend. See you later. Bye.